Hello and welcome back. In the previous section, we focused on highly available and fault-tolerant architecture, and in this section, we are going to move now into VPC networking for increased security, in which we're specifically going to discuss using a Bastion host and a NAT gateway. So, what is going on here? We kind of have the most complicated diagram so far, and I want to walk you through this step by step because what we have architect here in the diagram, we're going to build in the live lab following this lesson. So, when we talk about increased security for VPC, what we want to focus on is placing our EC2 instances that are holding our data in private subnets. However, this causes some issues. One, in that we then can't serve up web traffic from private instances since there is no route to the open internet. And also, we can't access or SSH into EC2 instances in private subnets or install or update software on them. However, with using a combination of an elastic load balancer, a Bastion host, and a NAT gateway, we can actually accomplish all of those things while still having our EC2 instance protected in a private subnet. So what we're going to do is we are going to create two EC2 instances in these two private subnets. So these EC2 instances will not have a public IP address. They will only have an internal IP address. Therefore, they will not be accessible from the open internet. However, using an elastic load balancer, we can actually serve traffic to these two EC2 instances and serve traffic back out to the open internet, but it has to be configured in a very specific way. And then we will set up a Bastion host so that we can SSH and access our two EC2 instances. And we will create a NAT gateway so our two EC2 instances can actually reach the open internet and install software packages. But first, let's talk about what exactly a Bastion host and a NAT gateway are. So first, let's focus on a Bastion host. So a Bastion host is an EC2 instance that lives in a public subnet and is used as a gateway for traffic that is destined for instances that live in a private subnet. So this means that we can use the Bastion host as a portal to access EC2 instances that are located in a private subnet. Now, a Bastion host is considered the critical strong point of a network, as all traffic must pass through it first. So if we take a look at it here, traffic coming from our AWS users through SSH is going to come down through the internet gateway and into the Bastion host, since the Bastion host will be in our public subnet that is associated with the route table that has the internet gateway attached. The Bastion host will then act as a portal for us where we can then access any other internal resources since we are now inside the VPC network. So if you recall, all instances within a VPC, regardless of whether they are on public or private subnets, can communicate with each other. So if we can access this Bastion host, then we will be able to access these two EC2 instances, routing traffic through the Bastion host. Now, again, what I want to make very clear is that the Bastion host then becomes the critical strong point of the network, and it means that a Bastion host should have increased and extremely tight security, usually with extra third-party security and monitoring software installed. Also, a Bastion host can be used as an access point to SSH into an internal network, meaning to access private resources within a VPN, meaning a virtual private network, and we'll talk more about virtual private networks when we get to our hybrid environment section of this course. So here's a nice quote by Marcus Raynham, and it just states that a Bastion host is a system identified by the firewall administrator, and that could be you, as a critical strong point in the network security. Generally, Bastion hosts will have some degree of extra attention paid to their security and may undergo regular audits and may have modified software. So again, a Bastion host is going to be an access point for us to other resources on the private parts of our VPC network. So again, in order for us to be able to access our two EC2 instances in the private subnets, we are first going to have to log into the Bastion host, and then from the Bastion host, we will then be able to SSH and log into either one of these EC2 instances. So this is how we can have EC2 instances placed in a private subnet, but still access them through routing our traffic through a Bastion host placed into a public subnet. Now, once we have actually accessed and are logged into the EC2 instances in our private subnets, we still won't be able to install any software or run any updates because this is just a one-way connection. We cannot send traffic from these EC2 instances out to the public open internet. So in order to solve that problem, we create what is called a NAT gateway. So let's talk a little bit about this now. A NAT gateway is designed to provide EC2 instances that live in a private subnet with a route to the internet so that they can download software packages and updates. A NAT gateway will prevent any host located outside of the VPC from initiating a connection with instances that are associated with it. A NAT gateway will only allow incoming traffic through if a request for it originated from an instance in a private subnet. A NAT gateway is needed because instances launched into the private subnet can't communicate with the open internet. And as we know, placing instances in a private subnet creates a higher level of security, but it also creates the limitation of the instance not being able to download software and software packages. So again, when we have these two EC2 instances in these private subnets, they currently are not able to access the open internet to download any software packages. But what the NAT gateway does is it actually provides a route for these two EC2 instances in the private subnets to reach the open internet and download software packages and updates. However, any host outside will not be able to reach either one of these two unless a request originated from these two EC2 instances. So this will not allow unsolicited incoming traffic. It will only allow incoming traffic that has been asked for by these two EC2 instances. So a couple of important things that you must know about NAT gateways, and that they must be created in a public subnet and they must be part of the private subnet's route table. So if we see here, the NAT gateway has been provisioned in a public subnet and it is associated with the private route table. Now, also as a side note, there are things called a NAT instance, and a NAT instance is identical to a NAT gateway in its purpose. However, it is executed differently by configuring an actual EC2 instance to do the same job. So the NAT gateway is a service provided by AWS, as where a NAT instance is an actual EC2 instance that we would set up and configure to do the exact same thing. Now, a NAT instance is starting to become more of a legacy feature in AWS. However, there still may be questions about NAT instances on the AWS CSA exam. However, the same principles apply whether you're talking about a NAT gateway or a NAT instance. So if you see a question on the exam and you say to yourself, it really sounds like the answer to this is a NAT gateway, but the only answer provided is a NAT instance, that is most likely going to be the correct answer, since these both serve the same purpose. They're just two different ways of doing it. This is an older way of doing it. This is an updated and much easier way of doing it. So that is an introduction to Bastion hosts and NAT gateways and how we can use them to have EC2 instances in our private subnets, but still be able to access them and also have those instances download software packages and updates. So next, we're going to move into a live lab in which we're going to set up this entire environment. But for now, we will conclude this lesson. Thank you for watching. You may now move on.